Okay, let's continue. I'm going to give you a little bit of a kind of ideas how this can be used, and then I got the password and would like to kind of demonstrate so you can see how simple is the utilization of the tool. I mentioned that tool comes with the technical and users manual. They can be directly downloaded from the website as well as from the research lab of mine. There is a user's manual which kind of leads you through the details of each screen and what and how you can use the tool. And the technical manual contains all the analytical, methodological presentations with examples from fitting the distributions to quantile matching algorithm for both gauged and ungauged. So because we do not have ability to provide a kind of technical support on a regular basis, these two documents are really very detailed or as detailed as possible to help the users. I was mentioning that almost at each step of the development of the tool, we try to verify the methodologies by publishing them in the international journals, getting the feedback of the peer community, as well as document the steps of the development that were of interest. Very large number of publications is generated. If you're interested, you can get them. Also, we did some analysis that are related to the tool but not part of the tool. Like there is a lot of discussion about use of regional climate models. And what we have done, we did the analysis and comparison between the use of regional and global climate models, and we basically documented that there is no significant improvement and there is a much less or smaller number of regional climate models available, so therefore the tool is still kind of utilizing the global models. So any type of analysis or any type additional analysis that we use, we publish, and we also make that available to the users so that the users can kind of follow at least and be informed what the tool is currently doing, what it may be doing in the future, and what are the kind of at least our judgments for now. Okay, this is a very common question when we go and talk to those who are utilizing the tool. And the main issue comes from the uncertainty that's being introduced in selecting the model, selecting the scenario, the RCP scenario, and the fact that use of different models will generate different IDF relationships. This difference is quite significant at some locations, and some locations is less significant, and that's where I think the users will need to make some judgment on their own how to deal with that. So the first step we did, we provided actually user with the information about uncertainty due to the model. So this type of box graph is produced for different type of, you can see for the particular distribution, for the particular scenario, where all the models, climate models are run. So you can see what is for the particular location, the range of uncertainty. This could be useful at least in making immediate judgment. Is your location subject to wide range of uncertainty or a smaller range of uncertainty? That really depends on the characteristics of the location. But that graph was produced. That graph was produced on the request of the users. This is what I am talking about. Use of various models, various climate models, may result in the range of IDF curves. So the shaded area, for example, shows all different curves produced for all different climate models in all scenarios. This is blue one is, let's say, the historical. That's the presentation for the London station where I am from. And you can see that there is a considerable difference, between the models. Now, there are three different ways how you can kind of use this. I think I touched a little bit on that first day when we were discussing about the kind of uncertainty in the climate future. Very common way and suggestion by the IPCC is always use all the models and all the scenarios together, lump them into a single into a single kind of combined scenario. And basically what you're doing, you're replacing this shaded area with a single realization. And you can realize that in this particular case, there is a considerable difference between, that aggregated information and the information that you may have by running different models. So this is what the IPCC is recommending, this kind of ensemble approach. And, literature, even the IPCC is in discussing in the reports, actually discussing the characteristics of the ensembles and issues that may be involved in the ensembles. They are mostly going into trying to explain why is this difference. And that difference comes from, various ways of modeling the physics within the climate models. And also the way how the numerical, these differential equations are solved. How is the choice of the numerical solution affecting the accuracy of the results? And there are tons of questions where basically use of ensembles may be seriously questioned. My really engineering kind of judgment, very simple. One is, if I am designing a dike or a levee to protect, the population where someone can lose their life, I would like to be on a most conservative side. And I would use, the most conservative estimate. If I'm not dealing with life, if I'm dealing with some losses, up to a certain level, I can consider the other choices. So kind of replacing with single one, if the range is large, is not, I think, acceptable solution. If the range is relatively narrow, then, you don't have to worry so much, and ensemble can be, appropriate. So you have to make a kind of engineering judgment. What are you using this information for? And how this choice may be affecting your activities. So use of ensemble is one way. Another way is what I was illustrating with that study we did for the City of London. I didn't go into details of the climate input for that study, but what we have done, we also considered a large number of climate models, and then we decided to perform the whole analysis for the bounds of this region. So we selected two models, the one that produced this upper bound and the one that produced this lower bound. And we repeated the whole kind of analysis of the risk of flooding in the city for upper and lower bound. So we carried the climate input through hydraulic analysis and risk analysis to see the potential impacts of the range on the final risk. So when the maps were generated for the city councillors and the decision makers, they had them for upper, for lower bound, for upper, lower bound. So they were able now to see first the difference, and also then to decide, which one they will use. So this was done through, I think I already talked, the climate, hydrology, hydraulics, and then the risk analysis, very detailed. The probability was fixed as a return period of 100 and 250 years, because these are the regulatory floods in Ontario, and then consequences, economic, monetary, combined into risk value, and then this risk value plotted as a shade of red on the map for different locations within the city. So you realize what we have done now, we had for a lower bound and upper bound. And everything was done for a lower and upper bound. And that was immediately kind of giving you the difference. You can see, for example, that more areas are at risk if you consider, the upper bound. And then by kind of focusing on these particular areas, you can see what is being affected and therefore make a decision what to use. Another suggestion that I made based on this to the city was to look at the difference. And these maps are nothing else than just these two values subtracted from each other. So then you can see where is the major difference occurring within the city, and again, kind of help the decision makers. Is this in a central part, urban, or is this more industrial area? Is this, so that immediately kind of helps you determine what is the potential impact of that range. Okay, and this is the kind of outcome I was talking about. You see, this is for the lower bound, and the kind of similar maps are generated for the upper bound. We also generated maps for these 12 types of infrastructure. So you have a map for the risk to roads, risk to buildings, risk to bridges, the water supply network, and so on. So you can actually extract all the risks that are being considered in this and present them from both upper and lower bound. And the third one is what I was repeating, a number of times up to now, that basically my feeling is that this will be the way of using the information from the tool like this, where you will be utilizing the detailed simulation model of your system, take the various realizations. So the whole range of these IDF curves can be used in simulating the future and observing what the consequences of that are. So that can be kind of combined. The detailed simulation model can be combined with the resilience idea and show you now, instead of a single value, the whole set of values that corresponds to. Obviously, the disturbances are now coming in this kind of form of the range of values generated for various climate inputs. Okay, so that's about it. If you have any questions, I can maybe clarify that. And my intention was maybe to use next half an hour, and we finish within that time, and demonstrate the tool so you can see how the tool kind of works. Any comments, questions? You guys are okay? Okay. So let's see how can we switch from this. So what should we do? Okay, so we are okay. So with the address IDF-UW-CA, you will be basically coming into the tool, and as you can see, this is the kind of current version of the tool. This is the opening screen. The tool is in this fourth version that I mentioned. I already logged in, and you can see as a user you're identifying the upper corner. If you're not registered, you will be kind of clicking on this and registering. For the registration is not of any other purpose except for us to know how many people are using. The basic information required for the registration is just your email, and the tool automatically sends you the password so that you can, once when you're registered within the tool with this ID and the password, you can access, and your space will remain first untouchable by any other people, except if you decide, because you have option to share your space with other coworkers if you're working on the same project and so on. Here is the in this initial screen. You have information on, what are the kind of new additions to the tool, and this is, for example, describing this addition that was done 2 weeks ago with the addition of new climate models. Then you have a previous kind of texts, and this is all at least the minimum that we think should be provided. And then if we have a particular publications and sources of information, the user is directly pointed to the source and can kind of find additional information. On the initial screen, you have options to kind of read more details about the tool, what the tool can do, what are the kind of key kind of publications, financial support, and things like that. And also you can access the or contact, send basically the email request, or by identifying yourself, providing email, and entering the message. The message can reach only 2 people, myself and Andre, who is kind of helping in administering that web page. And the response will be coming from one of us. Under these different menu options, you can also enter into different parts of the tool. You see that under the help, beside these questions and what is new, you have opportunity to access the manuals, and you can directly kind of download these 2 manuals that I already mentioned. So the updated interface is providing in a graphical form entrance into the tool for these, or entrance into 2 different modules. On the left side, you have a gauged, and on the right-hand side, it's ungauged module. And the difference is, as I was explaining, in basically ways and locations where you can generate. I'll kind of demonstrate both of them so you can see how it works. We'll start with the gauge locations, and the gauge location is basically opening the map of Canada. These circles and the numbers within the circles are identifying basically the number of stations that are stored in the database, and the number of stations for which we do have the observations. And you can see, as I was telling you, most of the population is a very narrow band, and you can see the very large number of stations. This is the area of kind of southwestern, Toronto and other large cities, Montreal, Ottawa. This is Vancouver, and so like, within this kind of range of the orange and red is probably 90% of the stations, and you have the whole country up there with a very, very small population and a small number of stations. When you click on one of these circles, you can kind of zoom in, and you can actually continue zooming in, using the zoom options until you reach basically the location of station. The cursor over the station is giving you the name of the station, and it's giving you the ID. The numbers are, associated by the government kind of numbering of these stations. And all this data is official data from the Department of Environment, Climate Change. If you introduce your own station, that station will appear in a different color at the location where you introduced your station, but it will be treated by the tool in very much the same data, except that you have to go through the procedure of introducing the station, and it's explained how this procedure is done, how you enter the data. Let me select one of the stations. So you start the process by selecting one. I was already showing you some pictures for the City of London, and I thought maybe I can. This is Toronto area. This is London. And I think this station is the London Airport Station. When you click, you can kind of select the station in this way, and then you will be provided kind of with this information directly taken from the database. What you see is the name of the station, the ID number, the geographic location of the station, and also you immediately see what kind of information or how much data is available, the initial year of the observations, ending year of the observation, and the total number of years. This is something that's, I think, essential, and again, the possibility of having a very short sequence of observations which may not be statistically significant for fitting or appropriately fitting the distribution. So you will be, if the number is less than 10, the number that's 65 here, you will get the kind of warning that this may not be sufficiently long data sequence or data series for fitting the distribution. Here you have the options to, I don't know why the resolution is so low. Calculating the historical, and the other menu option is calculation of the updated. So for the historical data, I said that we preserved the Gumbel distribution, and we opted to move the tool into the GEV. For the Gumbel distribution, the reason saving it is that the government is still using it. So the moment I clicked on the distribution, and the actually value was already calculated, and what you see in the table are now the IDF curves with the historical data for the City of London, 65 years with the distribution and calculated IDFs. The tabular form plot. Which are not showing up. And the equation. I'm not sure why we're not getting plots. Okay, must be some small bug. I have to look into that. Basically, plots are showing these numbers from the table and you know, fitted kind of equations. Many people like the equations, and these are the kind of results of fitting the parameters. So the line that is plotted through the idea of calculated values is converted in analytical form, and these equations are quite often used as a kind of fixed order location. So this is the way how you calculate the simple and historical data. The other option now for the gauge locations is to proceed with updates. And this is the first initial. Resolution is very low. You cannot easily read the text. We have in this case, the number of sub-menu options. The first one is choice of the kind of climate model and choice of the period. Then the calculation is done automatically for all three emission scenarios, so you have them as a separate menu option. So actually, you are not choosing the scenario. You can choose which one to use, but the calculation will be done for all three of them immediately. And the last option on this menu is that, you know, graph that was showing the box plot of the uncertainty range. So you see that the options or the period are next 100 years. So the updating or all the climate data is imported for the next 100 until 2100. And by simply moving this bar, you select the period for which you would like updating to be done. This is relatively easy task. This one is now the little bit more complex task. So you realize that now we have this choice of the climate models available. And as I was pointing out, there is 24 of them. They're all identified by their names and original source. The climate model data is provided by the climate centers that are kind of running these models. And there are distribution platforms around the world that you can kind of download the data. We are regularly checking the availability because these centers are, for example, generating new runs and performing some improvements, modifying the versions of the models. Like Canadian center is in a 4th version, German one is already, I think, in a 5th or so on. And this is permanently being kind of updated in our database. So what we have in the database is really the most recent information. Downloading this data is pretty demanding process. There are millions of pieces of information because you're downloading for all these different locations, and you're downloading for 100 years of daily data. So the way how the choice is being done here, you can kind of select the model and then proceed, and for that particular model do the calculation, or you already have prepared ensemble. Here, this is the all model ensemble that kind of combines them all into a single ensemble. And I said the third way of using is by selecting the certain number of models, so like creating a smaller ensemble on your own. And that is being done by kind of running the system for the selected models, 2, 3, how many models you want to combine times. I'll run first one, just a ensemble. This is the choice that is still available. We preserved the raw climate models as in the original version, and we also provided the option to combine and use the 24 of the bias-corrected models that are right now the kind of state-of-the-art climate information for Canada. So we were thinking about eliminating the initial option so that the user is only presented with this state-of-the-art data, but we got some reaction that the people were using the tool already for 2-3 years, and they did some work with the previous, so they still would like to have access to this work, in spite of the fact that newer climate products are available that are probably better. So for now we are still keeping them, but permanently thinking about reducing the options, because the moment you have more options available, the users become more nervous, what they should be using in their analysis. So for the selected, I selected here, I don't know how many years, 8 years, and for the this all model bias corrected all models ensemble, we can calculate the IDF for the future. You click on it, and now the data is being extracted from the climate databases. The calculation is fitting the distribution is being done, and the matching algorithm already generated the outcome. So you see how many seconds that took, to do the whole calculation. So what you see here is now the options for presenting your results. Again, the tables, different return periods, different durations, and intensity, as well as the total precipitation. Plots, you see the plots are working here and didn't work in a historical, so there is a small problem. Plots are now provided, as well as the interpolated equations together with the kind of uncertainty plot. So you see for the London station, for example, the range between these 24 different models, because I'm presenting the scenario, is it's not extremely large, but I think it can be quite significant for the larger return periods. By changing the return period, you will get the box plot that correspond to that particular return period. And you can see with the larger, return periods, we have a, increase in the uncertainty that comes from the choice of various models. I mentioned that here you have options, and that was again done to kind of satisfy the needs of the users of bringing the data out of the tool so that they can be used in the reports or for further analysis. So here is the way of downloading the images, downloading the data, downloading the files, bringing that into Excel. The options are immediately done, or the calculations are done for the 3 RCPs, 2.6, 4.5, and 8.5. So you can very easily show the different plots for different scenarios. And also we provided here the kind of comparison plot. So this is the one return period, and this is now the basically presentation of 4 IDF curves for that return period for that station. And the different color in this particular case, the scale is, or the difference is small. You have 2.5, RCP 4.5, 8.5, and historical. So this is basically showing you what the climate change is doing to the London location for the 2-year return period. You can obviously change the return period and do the presentation of the kind of similar comparison graph, and you can see how they change. So this will be, I think, more or less everything for the historical, for the gauged locations. I'm just trying to remember, did I skip anything? I'm skipping entering your stations because it's a little bit more, it's just a little bit more demanding, and you have to go through the steps how to bring the data from the, we created the tool to help you bring the data directly from the spreadsheet into the format that database requires, and the moment when you kind of copy that spreadsheet into the tool, then it's stored in the database in the same format as other historical information that we took from the. Okay, so now if we actually go through the ungauged locations, do you have guys any questions about this part? Yeah. So this is all available for 700 stations that are providing the measured subdaily data. For the ungauged locations, you start by selecting the path, and now the modified algorithm is available that is utilizing these reanalysis products. And I mentioned the way of kind of starting is, just selecting the location, which will be immediately identified by the latitude and longitude, or by simply entering this information here that will bring you to the location of interest. These are some demos being obviously done. Okay, so I'll just select one location arbitrary, and this will be identified here. Where is the location? And again, the kind of process and the screen and the communication and the interface, user interface is very similar to the kind of gauge locations. You have the options of the historical analysis or analysis of historical and updated, but historical here is not observed. It's that product that in a gridded form covers the whole country, and it's obtained by using reanalysis information, observed data, and the regression analysis, sophisticated regression analysis I call. But for the user, everything looks, very much the same. You kind of for the selected location. By clicking on the historical, you immediately get calculated the values. These values are from that initial product, the plots. So something with the historical plot is not appearing. I'm sorry about that. Obviously equations are being done. So the data is calculated, it's just the plots are not showing up. For the updated climate, now we go into the matching algorithm, but for the user, again, the choice and the screen remains very much the same. You see that you have to choose the period, you have to choose the model, you will do the calculation for different RCPs, and you can kind of do the comparison. Let's do the calculation for one model. I used, let's say, the Pacific climate. Yeah, that's a Canadian model. The clicking on the calculation, select at least 30 years. Oh, I didn't select, sorry. Something is not picking up here. Your mouse is, it seems that it's not picking up the point. You see, somehow gets stuck. I don't know, can I do that by... Okay. Having trouble with the mouse. Okay, when you select the period, when you select the model, now the whole calculation process is being performed. The 4 different IDFs created, and the final user presented with the medium one. Again, in a tabular form, the total precipitation and intensity options, plots, equations, and the kind of uncertainty that kind of covers the whole different set of models and the scenarios. This information you can generate for various RCPs or the emission scenarios, and again the comparison gives you the variation between the historical and the updated or the curves under the climate change. I think that's approximately, except I did show you everything except how to import your own data, maybe I can come back and just show quickly at least the initial screen for doing that. So for the gauge locations, when you come into the gauge locations in here should be the option for managing stations, and this is the kind of screen that you will be presented. In this screen you have now the list of all the stations that are being stored, and this is basically the review of the database with the observations, and under is the option that I was mentioning for adding or creating the station, and that's now simply requiring user to provide the observed data in a similar format as the data that are provided for the observed stations. You have to identify the name, provide the location. If you have ID number or any description you want, you can say my station or our station and so on. You will have options to select the durations for which you have the measurements, and then when this is all done, the table will reappear, which you will be copying actually the data directly from the spreadsheet into the tool. When this is done, and when the tool reads in, this station will appear in the list of the stations under the name that you kind of enter the station, and become part of your database. For that station, you will have opportunity to identify now, do you want this station to be public so that others can see and use the data? Do you want this station to share with other users of the tool so that a limited number of you, maybe people working within the same organization, can share that? Or do you want only to have this for yourself? I think I did cover most of the features. You see that use of the tool is very simple, very straightforward. Most of the stuff is being done in the background, and I must tell you that could be the kind of double-sided sword. Some people, because of the simplicity, do not fully understand the methodology in the background and may misjudge the tool. On other side, some people, because of not kind of knowing what's in the back, do not fully kind of believe. So we tried through the workshops and the direct communication with the users to kind of answer these questions with the very detailed technical and users manual to actually cover the ground and provide in a written form all the information about the tool. But we cannot do more because we are not a professional organization. My dream was that someone like, Government Environment Canada would take over the tool and maybe make it part, but that's not very simple in Canada. I'm not sure about Brazil, but here, guys, I am kind of finishing for today. If you have questions, comments, if you want to discuss anything related to this, I am open for that. Do you have any questions, or what is your impression about the tool?
I'm going to talk about my impressions. It's a very impressive tool.
Thank you.
And I wish we had something for Brazil, but...
Yeah, but...
para eu levantar.
Yeah,
to stand up.
Yeah.
And...
That will be great. With Professor Mario, we were talking about the potential for the collaboration. So let's say the expertise, our expertise in development and so on, can be transferred to if there is interest for developing something similar here, someone can come to Canada, spend some time with us, discuss the development issues, discuss the methodological issues, but that development needs to be done in-house. It needs to be done here because in what form are your data saved? What do you have from the data access? How is this being updated? These are all the questions that are very technical questions, but they're basically in the background. I mean, the development of that database, it's not, it requires, the standardized presentation of the data, standardized, updating of the data and everything else. So at the surface, it looks nice and easy, but there is a lot of work that goes into making it, nice and easy.
Yes, I think it will be very easy to do as like you have done before. So it's going to be just replicate something.
Yeah, what you can do is, that will be my kind of suggestion, because you can easily register. and use it. So but be careful, use it only for the stations in Canada. It will I was talking to Andre actually to prevent any other location outside of Canada because some people do. I know that the colleagues in the United States, especially who live very close to the border, are using it. I know that for sure, because that's a relatively similar kind of climatic region. But using it in the Caribbean, it's very wrong. Very wrong.
Yes.
What you can do is, by logging in, you can kind of demonstrate, how this looks like and how simple it is, and maybe, start the dialogue about potential development. We are very much open for the collaboration and transferring our knowledge and experience, but I think the work needs to be done here.
Yeah, sure.
Yeah.
Thank you, Professor. It was really great.
That's good.
Alguém quer falar mais alguma coisa? Você gosta de falar? Ninguém mais tem nenhuma pergunta? So, anyone have any more questions? No? Today in the afternoon, we'll have some monitoring with the Professor Simonovic. So if you want, you can come, talk directly to him. It's not going to be a lecture. It's more to change information and ask directly for him any doubts. So it's not mandatory. You can come if you want. But I think it would be a good time to talk a little bit more with him. So we would like to thank you, Professor Simonovic, and we see later in the afternoon, okay?